I'm Sheila Roberts. I'm a professor of geology at University of Montana Western, and these signs were created in concert with the other professor of geology at University of Montana Western, Dr. Rob Thomas. Let me just tell you a little bit about the story of these geologic road signs, and I won't take too much time with this, but I'm a Montana native, but I spent about 10 years living in Wyoming. As I was driving about Wyoming, I started seeing geologic road signs in places that the Wyoming Geological Association had put out. This Wind River Canyon has these wonderful signs telling you what kind of rocks you're going through. Then we came back to Montana and started looking around for geologic road signs, and there was like almost nothing related to geology. There's plenty of history. And of course, history is the first thing that people connect to. Because it's people. But there's all this other part of time. You know, human history is just a little scum on the surface of geologic time, and we've got all this other, 4.5 billion years that nobody was talking about in Montana. And of course, human history takes place on the landscape. And Montana's human history from the very earliest records of human history, which are things like the quarries that Native Americans were working 14,000 years ago. Human history in Montana has always been related very much to the landscape. And so Dr. Thomas and I got together and said we should build a legacy of geologic road signs for Montana. And so we wrote this federal grant proposal. It's actually, the pork barrel kind of federal grant proposals where you're asking for money for a specific project. And we asked for money for a project that would have covered the whole state of Montana with geologic road signs. And we got about a third of what we asked for, which is typical. And so that money also was appropriated, but it came through the Montana Department of Transportation. And we needed a theme because we didn't have enough money to put signs everywhere. And this was 2001, 2002, and the Lewis and Clark expedition was coming up, and we wanted a theme that would allow us to put signs across most of the state, but have some kind of, carry through theme. And we also realized, and had realized for a long time, that people are first drawn to history, and then you can draw them to talk about rocks. And so, and we're not historians, but we got out the Lewis and Clark journals and started reading and said, these people must have been aware that they were traveling through a landscape and interacting with the geology of the place. And it turned out, of course, that they were, because although they weren't trained geologists, they were very skilled observers, and they observed geological processes wonderfully, and they were not expecting to find a lot of interest in terms of mineral wealth or those things that people had been tromping through here, the Spaniards, everybody else in this part of the world in the West looking for gold, and discovered that the Native Americans were not laden with silver and gold jewelry, and and if they had, it was clearly traded with people in Mexico and farther south, and so they weren't expecting that kind of thing. Thomas Jefferson told them to look for copper, for building stone, check out the water, check out geothermal resources, maybe look for other kinds of things, but not really expecting to see it. Look for soils. All of those things are geological, but they're not the mineral wealth. And so they came out here, and if you've read the journals, you know that most of what they were describing was the biology and the people. But there are a lot of things tucked in there. And so we went through the journals and started looking for places where they knew they were interacting with the landscape, where they had time to. In some places, they were just in too much hurry. For example, when they were coming through the Bitterroot, both ways, that they were in too much hurry to spend a lot of time commenting on the landscape. And so we didn't put a sign there. What they did notice on several occasions was that they were crossing creeks that had big boulders in them. And those big boulders were hurting the horses' hooves and hurting people's feet. And those big boulders had come rushing out of all the canyons in the Bitterroot Mountains during the last ice age as glacial outwash. And they were still sitting there as sort of relic features in those creek beds. But here's the deal. We didn't have very much money. We needed places. If you're going to put up signs, interpretive signs, you need a place where there's something to interpret, where you can see something, where people will be in a place where they look out. And you also, for us, we needed it to be of geological interest. We needed public access, and if it wasn't public land, then we needed sort of long-term assurance that whatever private interest held the land, they were going to be interested in letting us put those signs up and let people come and look at them over a long term. And that was the main part of it, but it took an incredibly long time to get that. When we first got the grant through the Montana Highway Department, they were sort of floored because, of course, they hadn't heard about it because we didn't know how the money was going to appear. And they weren't very happy because they thought there were a couple of wild geologists who were going to put a geologic road sign on every blind corner in Montana. And we didn't do that. We weren't planning to do that. But what we ended up doing mostly was working with the national parks, state parks, the BLM, the Forest Service, and a few private interests. And that's where the signs sit now. And when we ran out of money, we ran out of signs. So there's a map over here that shows where they are. We did manage to get the farthest possible east point that we could find as the Lewis and Clark expedition came in. It's listed there as the Fort Union Trading Post, and if you've been out there, you know that Fort Union Trading Post actually sits in North Dakota, right? But their parking lot is in Montana. And there's a nice little walkway that has some other interpretive signage up there, and then there's the sign that says Montana, North Dakota border, and our sign is just on the Montana side of that, and that's as far east as we could get. The park people actually offered to pick up that sign and move it over a little bit if we needed to have it someplace, but then we didn't need that stuff. So anyway, the first sign is there along the walkway. One of the things you may have noticed is that the color combinations are not exactly the same, and the styles are not exactly the same in all of these signs. And that's because if there were already signs in these locations, we tried to make them match. And this one matches as closely as possible the other signs. What this has, if you get a chance to take a look at this more carefully, what this has are two maps that were available. Actually, sorry, this map was available, and Lewis and Clark had it with them. It was constructed in 1802 from precious little information, but it did have the few sites that they actually had latitude and longitude information about. They knew where Fort Mandan was, and they were planning to spend their first winter out there. And they knew where the Columbia River arrived at the Pacific Ocean, and they didn't know much in between, and you can see that from this map. You know, that's what was known. This little dark line right here is a thought. They knew there were mountains. They knew that there would be a continental divide at some point, and that, you know, the water that was going down the Mississippi, down the Missouri-Mississippi, would be on one side, and the other side would be the Pacific Ocean and the Columbia River. They actually had some pretty optimistic ideas about what the continental divide was going to look like. They didn't know for sure, but they had heard that there might be a sort of wide plain, high plateau of sorts, and that's where all these rivers started. And so you would get to the top of the Missouri River drainage, cross a fairly wide plain, and come down the Columbia, and it might even be close enough that they wouldn't even need horses. You know, although they suspected they would need horses to make that space, but they didn't know, and they didn't know how far west it was. But they did know also the altitude of where they were leaving, and where they knew about sea level, and they knew that the continental divide was going to have to be. It was going to be the same fall, the same altitude fall from the continental divide on the way to the Gulf of Mexico as it was going to be on the way to the Pacific. So what that meant was the farther west they got before they got to the continental divide, the steeper it was going to have to be on the west side. Yeah. But the good side was the farther west they got, that was the boundary of the Louisiana Territory. So if they could go farther west, that was good in terms of the extent of this territory. So here we go. Now, I don't know about you, but my idea of a fun time is not pushing a bunch of boats upstream for a couple of thousand miles. But hey, this was a different time. These people were adventurers. And this one now is that farthest east. When they got to the Mandan villages and spent their first winter of 1805, they had an opportunity to talk to a lot of people because there were many tribes who were spending the winter there too. Many of those people had spent their lives in the land that Lewis and Clark and their expedition was headed to. And so they got a lot of information about what to expect, but they still didn't get enough information to know what the continental divide was going to be like for sure. They started up this is their trip out in red here. And the next sign that we have is a place along the Missouri River. I don't know if this helps or not. Does this help to look at this one? Do you want to hold it? No, I'm okay. I think I can do this for now anyway. If I get tired of it, y'all can see this. So they're following up the Missouri River, and they came to the confluence with the Milk River. And Clark climbed a hill where he could look down and see for sure which river they were supposed to go on, because as it turned out, the valley of the Milk River was as big as the valley of the Missouri River, but there was less water in it, so it didn't take them very long to figure that out. But the interesting thing from a geologist's point of view is that valley of the Milk River is believed by many geologists who work there to have been the ancient valley of the Missouri River before the Ice Age. And so it wasn't surprising that the Milk River looked kind of what they say underfit for the size of its valley. And this shows where the ice was, the last big ice. They're right there. This is the Milk River, where the Missouri used to go, and also then used to go north out to Hudson Bay, and it was pushed south. And that's what you see there. And the other thing that Clark noticed when he got up on this hill was all these big rocks laying around. And he even mentioned that they might be good for building stone. And most of those big rocks are glacial erratics brought down from Canada. You can take a look at those. So they're big hard rocks, and they don't look like the other rock that's there because they came from 1,000 miles away. Anyway, so here they are again, interacting. Question? Was there a question?
Yeah, I said we do have an easel.
An easel?
Yeah.
Oh.
Would that be help?
If there is, or you know what, I could set it here, but the problem is, you let me know if it's reflecting strangely, okay?
You need an assistant. Francis will be glad to come here.
Okay, well actually Tom would be glad too. I appreciate that. Let's just do it. Can people see this? Is it reflecting strangely? Okay, let's do it this way. Okay, so the next one is on down the way. We're now at a place called James Kipp Recreation Area. There's a major highway crossing of the Missouri River at this spot. There isn't much access between here and there for public use, and so the next place is this sign. And one of the fun things in the Lewis and Clark Journal is they were encountering a lot of wind out there, and on the day that they passed this site, they said there was so much wind that they put their sails out. So they were sailing upriver, which is a lot of wind, those big heavy boats. And as it happens, if they had been there 65 million years earlier, they would have been sailing on an ocean, an inland sea. Oh, thank you. What I'm trying to avoid is reflection of that so that you can't see the sign. How is it?
It's entirely acceptable. It's not perfect, but it's fine. We can see it.
Okay. Thank you. All right. Okay. Some other things that were going on in the Lewis and Clark expedition besides sailing in an area that was once covered by ocean is that they've been having actually quite a bit of trouble with the streams coming into the Missouri River, and in some cases the river itself, because it had salts in it, various kinds of salts that were weathering out of the rocks, especially the Cretaceous shales. And they didn't know what the salts were, but they were blowing into their eyes. They were giving them diarrhea when they drank the creeks coming in. And so there was a place where they were interacting with the geology, but they were interacting with a much older geology than they realized, because when this ancient sea was covering this part of the world, it was depositing black, shaly, sort of deep sea, not deep sea, but oceanic looking rocks, and those rocks contained the salts that were then weathering out and drying up along the edge of the river, or coming down the creeks, and also being recrystallized in the rocks. I'm going to pass this one around. These are gypsum, beautiful little gypsum crystals that they found laying all over on these black shales, and that you can find today. They're actually growing. They're calcium, it's a calcium sulfate, a hydrated calcium sulfate crystal. And they invariably call this quartz. It's not quartz. They weren't mineralogists, they weren't petrologists. They had had a little bit of training in geology before they left. Lewis had specifically, but geology was in its infancy at this time. They left in 1803. They were a year behind the father of geology's first publication that nobody really understood anyway, and it didn't get to the U.S. by that time. It wasn't until about 30 years later that a real geological society was born, 20 years anyway. And so there wasn't a great deal of geology to learn, although there was plenty of mineralogy around. They could have understood that wasn't quartz. If you scratch that with your finger, with your fingernail, it will scratch because it's very soft mineral. Had they bothered to do that, they would have known it wasn't quartz. Anyway, that's okay. They weren't interested in quartz because they weren't looking for mineral deposits of any kind. One of the really, I think, tremendous observations that Lewis and Clark made in this early part of their trip across Montana was recognizing and understanding the process that formed clinker. Nobody had described this before. They couldn't have had training for it. If you've been in eastern and central Montana, you may have driven along and seen these red tops of mountains. If you haven't, there's a picture of one right here. This is the Terry Badlands that have been cut down into and carved by water over thousands of years. And the very tops of these things are often held up by a red rock that's called clinker. And Lewis and Clark saw this and initially identified it as an igneous rock. They thought it was a lava. And they thought that because in some of these pieces you can actually see drips, melted drips, and there's a picture of one right here, which you can probably all see, where the rock melted and flowed down. And so initially they said, well, this is an igneous rock. This is a lava. And then they kept watching and kept looking for the appearance of this and realized that they would see a coal bed coming along, and then the coal bed would disappear, and there would be clinker, and then the coal bed would reappear, and there wouldn't be clinker. And they put it together and said, I think the coal was burning and has melted this rock. And that's dead on. That's what happened. So just one of those little things. They weren't being paid to make these kinds of observations, but they were looking around and seeing the landscape and interpreting it. So here's one of the coal beds out there. There's a lot of coal. Badlands are fun. If you get a chance to go to the Badlands, the Terry Badlands is one of these little hidden places that people who don't live around there often don't even know is there. But there's a windy little dirt road and this gorgeous viewpoint where you can look out on this carved landscape with the red tops all over the place.
Where are the cherry beds?
Terry?
Okay.
Terry, it's just immediately you drive through Terry and up a dirt road and there it is. And it's, yeah. And anybody in Terry will tell you where it is because they're very proud of their Badlands. But, and Lewis and Clark, of course, were noticing all this stuff. They didn't go to this overlook site, but they saw and commented on it as they were going along. Here's a cross section.
It wasn't marked when they went through there.
Pardon me?
It wasn't marked when they went through there.
I'm sorry. We should have told them to at least leave a marker whenever. That's right. Yeah. Yeah. You know, the Lewis and Clark expedition is a great national treasure because it has the record of what this country looked like before all the white folks got here.
Is that right?
Yeah. Okay, actually I'll put a couple others up. These are just, here's one. Oh dear, let's see. Okay, this is Gates of the Mountains and it's a small one. I'll just pass it around. Gates of the, as we move on along here, here's the James. Oh, actually we're going to do Great Falls next. The Gates of the Mountains is passing around, but let me talk about the Great Falls. I have two signs actually for this, and we were allowed to put them at the site that is maintained by the power company, right below the dam that now covers the gates of the Great Falls of the Missouri. The Great Falls was one of the landmarks that Lewis and Clark had learned about in the Mandan villages. So they knew that sooner or later they were going to get up to a place on the Missouri River that they weren't going to be able to push their boats up. They were going to have to get around it. A wonderful thing happens at the Gates of the Mountains, at least if you're a geologist. This was a wonderful thing because mostly the aesthetics of this trip, where you hear in the journals you read a beautiful level plain, a beautiful green plain, a lovely level plain, a lovely level valley. The aesthetics of this expedition for these guys was, where could we put a human habitation? Where could we have farms? What's beautiful in that sense? When they finally get into the mountains, they talk about them as immense, as stupendous, as overwhelming, as awe-inspiring, depressing. That's how they felt about the mountains for the most part, as opposed to the level plain where you could bring people in, bring farmers in, have a city here. But at this place, Lewis is totally overcome by the beauty of the falls. And he goes on and on, page after page after page, of how beautiful these falls are and how he just doesn't have the words to describe it. That he goes on and tries to get the words to describe it. It's the single longest description of beauty in the Lewis and Clark journals. He was pretty pleased when they passed the white cliffs in the Missouri also, but this one just overwhelmed him. And it's too bad we can't see it as it was, but there are some pictures. Before the dam went in. Yeah. Yeah. Flip it this way a little bit, I think, for the light. Is that better? Yeah. So that's what it looked like when Lewis and Clark stood and observed the falls. This is a kind of a view from above, and that's a view from down, looking at it head on. This is what it looks like now. One of the nice things about the dam for geologists is that you can't actually see the rocks, and so it's not all bad. The most of the water is now coming over here and going through the power plant instead. Thanks, Tom. Appreciate that. So the aesthetic value of this falls actually overwhelms his fear of what they're going to do to get past it, which was nice. They do eventually get around it. But the story of the falls here, the geologic story, is actually similar to the story of the Missouri breaks on down, and fits in with the story that I mentioned at the Milk River overlook. The Missouri River is not traveling in its oldest valley. It was disrupted and kind of deranged a little bit when the ice came down and pushed it out of its channels. And so one of the places that it was pushed out of its channel, oops, that's on that one, was at the Great Falls. There's a little map right here. Here's the Missouri River. This is a series of falls. If you've been to Great Falls, you know that there isn't just one. There's a whole series of them going down the river here. This is where the river had gone before the ice came down, and there aren't any falls on that path. It had had time to carve a smoother route through there. So part of the evidence that this is a new route is the existence of the falls, because what you have there in terms of the bedrock is soft, shaly rock, and then a hard sandstone, and then some more soft, shaly rock and a hard sandstone. And over time, the Missouri River will even that hole out and be just a more even gradient through that. But it hasn't had time to do that, and so the falls are what's left of that. And as it turned out, that old path of the Missouri River is a bit of a valley, and it's what they used as their portage route to get around it. Part of, anyway, their portage route. So it was useful for the beauty of it, and then also provided a way to get around. This is a nice spot. They've got a lot of other interpretive signage. The rocks that were deposited at this place are partly marine and partly non-marine, because they sat right at the edge at this time. Here comes the sea again. The seas come in and the seas go out through geologic time. And this sea at this time didn't cover all of eastern and central Montana. Instead it was coming down a trough that had formed about 70, 80 million years ago in front of the rising Rocky Mountains. The Rocky Mountains had been shoved up and were weighting the crust out in front of them enough to make a trough, and the sea came down that trough. And it came down about that far at this point. And so these rocks are partly marine and partly shallow marine and partly non-marine. And the sea, the shales and sands are the non-marine part of that.
Could you tell me what that globe is in the middle? Is that before the continents?
Yes, the globes, there are several of these globes. There's a couple here, and there's one in this one, which I can pass around. This was actually the sailing spot. These globes were produced by a fellow named Robert Blakey. Ronald Blakey, I'm sorry, they're reconstructions, they're paleogeographic reconstructions of the Earth at these times. And so if you get up close, what you see, here's South America, here's North America, and here's that sea coming down from the north. As you can see, a lot of the southern part of our what's now the United States was also covered with water in that time.
Is that South America and Africa?
Yeah, South America and Africa are attached here. Yeah, this is if you've heard about Pangaea, Reunite Pangaea, Gondwanaland. Anyway, it's beginning to break up. This is 100 million years or so after the beginning of the breakup of Pangaea. But South America and Africa have not separated yet. The Atlantic Ocean is beginning to form, but hasn't gotten very impressive. Back here, let's see. This one, in this case, these globes are just to show the extent of ice during the Ice Age and the extent of ice now, which, as you know, is rapidly diminishing. So they got to the gorge, or the falls. They got around the falls. And they started up. I'll put this one here. They started it up. You guys are, let's see, that's as the gates of the mountains got all the way around. It's right there. Yeah. So they, after the Great Falls, they travel through what is still kind of largely plains, although they can see the mountains coming. And then the Missouri goes into a canyon, and they decided to call that the Gates of the Rocky Mountains. And that is a small version that's going around. And as soon as they hit what is now called the Overthrust Belt, it's the part of Montana in the west that has experienced this great shoving of rocks event. When there was a subducting ocean floor about at westernmost Idaho, westernmost Idaho, and mountains rising and volcanoes going off and things being shoved this way. And at the gates of the mountains, they're going into that. So you start seeing a particular kind of rock that was really handy for Lewis and Clark, especially for Clark, who seemed to be the guy who was usually climbing up to get a good view of things. And one of the most common rocks that he starts climbing up, and kind of a theme in this part of the world, is the Madison limestone. Madison limestone is a great thick pile of mostly shallow warm water kind of rock that's composed almost entirely of the internal and external shells and skeletons of animals or even plants, because some algae produce these things. So there's this huge pile of limestone that has turned into rock. It covers, although it has different names, it covers much of western United States and Canada, a similar kind of thing. It's middle, question?
Now, go ahead, finish your.
It's 300 some million years old. You could have snorkeled from Missoula to Lemhi Pass, or anywhere pretty much you wanted to snorkel in western and central Montana at that time, and you would have seen these critters growing at the bottom: corals, bryozoas, brachiopods. Lots of activity. There were sharks in the water. Find shark teeth every now and then. But the legacy of this stuff for the Lewis and Clark expedition was cliffs, because in this part of the world, that kind of rock doesn't erode very quickly, and it tends to form prominences. It formed the prominence at the Three Forks that they both climbed up to look at. It is Beaverhead Rock. It is Clark's Lookout. It's a whole bunch of other little high points on the way, and big high points. And this sign is down at Clark's Canyon, where, if you've been there, this was Camp Fortunate, where they finally got to the confluence of the two streams that created the Jefferson River, having followed that one up. And lo and behold, there's a beautiful level plain, which is now covered with water, surrounded by prominences of Madison limestone to climb up and look around. And so we have this sign there and some information about the critters. And here's another paleogeographic reconstruction. Here's Montana. And this is the extent of that sea. You get a kind of sense, mostly shallow. Seas that cover continents are typically, shallower than seas that cover oceanic crust. And this was, here's the equator at that time, running right through about where we stand. So the this was Margaritaville. In Montana's geologic history. Still is, that's right.
The banana belt.
That's right. You had a question.
Back up a little bit. When they were up around the Great Falls, they heard all these booms. They thought it was a cannon. And can you explain that? And it had something to do with the rivers or the flow or something.
Oh, let's see. I remember reading something about that. There are some people who believe it was just the big rocks moving in the falls. Do you know something about this that I...
All I know is that Lewis heard them,
Uh-huh.
and he thought that it was a cannon going off and stuff.
Yeah. Anybody else know about that?
Are you referring to the winter period, or they were on their trip?
No, this was in July of
Yeah.
05.
Yeah, uh-huh.
And it was never explained, and as far as I know, I don't know if anybody ever recorded hearing it after them.
I don't have an explanation for that, a geological explanation. I know that if you stand anywhere near any of these rushing streams during high water flow, you hear big booms. And some of them are big enough to think of a distant cannon. And what it is rocks that don't move any other time of the year. But if there's enough water flow, enough power in that river, they can move boulders. But I don't know that that's the answer.
I just thought maybe there was something connected to the geology there that was causing it.
Well, let me say that I'll bet it was geology. How's that? Okay. Yeah, or let me talk about one other one first. A small one. How are we doing for time? Yeah, we're okay. Okay. So, I'll just pass this one around. A lot of things happened. One of the really amazing things, and there's two signs that relate to this. Lewis and Clark saw the mountains coming, and remember, they really don't like mountains. They're awesome, but they're not interested in crossing a bunch of mountains with, and they don't have the means to do it yet. So they see these things coming when they're out, in Great Falls. They can see the mountains. They get up on prominences. They can see them, and they're thinking, we haven't seen any Indians since we left Fort Mandan, basically. Certainly none in Montana. We know we're going to need horses when we get to impassable water, and we don't know what's coming up here. But what happened was they start up the river. They go to the Three Forks, and they choose the Jefferson, and they start pushing the boats up the Jefferson River, and they see a mountain off in the distance, and they think, okay, here's where we're going to have to get out. And the river goes right through the mountain, the hill. And then it goes down through another valley, and they see the mountains coming. And they say, okay, here it is, And the river goes right through the mountain into another valley, and it goes again. And at one point, so this is the river entered the mountain. This is one of the places where it does that. This is they've been up through the Beaverhead valley, and the river goes right through what they called rattlesnake cliffs. They can see the cliffs, and they could actually see from some distance that there was going to be a cleft in this. And by that time, they were being guided by Sakatawea, who also knew that it was going to go on through. But the story here appears to be, geologically, well, there are a couple of different interpretations of this. One thing that's happened that they didn't understand because they'd never seen anything like this was that this whole part of the world has been uplifted and pulled apart. And that pulling apart is something like a loaf of bread that you put into the oven, and the surface of the loaf of bread covers the loaf of bread, you know, the dough when you put it in. But it begins to rise, and the surface is already hardened a bit, and so it has to crack and pull apart. And you get, you know, this isn't exactly the analogy, but you get high points and low points. You get valleys and ridges. And it isn't just a matter of pulling it apart. It's a matter of extending it because you're rising it. You're raising this whole country and pulling it apart. And in the process of doing that, there are mountains and valleys. The valleys have dropped down relative to the mountains. Everything has risen. So we're, you know, the valleys around here are not sea level kind of valleys. They're high too. The whole area has risen, but there's a mountain and it has faults, and there's a valley, and then there's another mountain and it has faults, and there's a valley. And it's the extension of what's called the Basin and Range Province that you see if you've been in Nevada and southern Idaho. We get that up here too, in this part of Montana. And it has complicated the scenery a lot, but it has created these valleys and mountains, and in some cases, apparently that rising happened after the rivers were already established in their path, and happened slowly enough that the river decided not to move. It just decided to cut its way through. I'm sorry for anthropomorphizing this, but you know what I mean. The river's already established, and once it begins to cut down through the canyon, then it's confined by the rock, and so as it rises more, it has to continue to cut down. And so that explains, at least in some places, why rivers, instead of going around the mountains, go right bloody through them. And that was wonderful for Lewis and Clark. And for their going up here. Let's see.
I'm going to ask on that point. Is that my understanding? Is that what happened with the Sapphire Mountains? That they kind of broke off of the Bitterroot Mountains?
The Sapphire Mountains have a different story. Yeah, and you know, we would have loved to do a sign with this, but Lewis and Clark were just buzzing through here, and they didn't say anything about the Bitterroot Mountains except to mention that they had snow and that there were creeks, and so we couldn't legitimately put a sign describing the history there. Do you mind if I digress for just a minute from Lewis and Clark? Many of you have probably already heard this. By the way, I'm going to pass this around while I'm talking. This is Clark's Lookout down by Dillon, and it shows the mountain rising and the valley falling, and that's really the whole point of doing that. The story of the Sapphire Mountains, the fun story, and I think the most recent and pretty well accepted interpretation is that the Sapphire Mountains slid off the Bitterroot Range. So why not? You know? The Bitterroot Mountains up here are part of what's called the Idaho batholith, the Bitterroot lobe. It's ancient igneous rock that started forming pods of it 90,000 years or 90 million years ago and continued up to about 60 million years ago. While that rock was solidifying, it was deep underground, but it rose, apparently, while it was still pretty warm. And, you know, there's a lot of more description of this, but apparently the sapphire block was the rocks that sat on top of that that solidifying igneous rock, and when it got to gravitational instability, it went east. And there's some evidence of that, some really interesting evidence. If you drive into almost any of the canyons in, from here to, well, I guess all the way down the Bitterroot Front, you may see in the first rock that you get into is this just stretched out. You can tell that it looks like it's just been taffy pulled. Tends to be kind of dark colored. There are strung out crystals. That is the interpreted surface of the slide off. So it didn't happen without completely traumatizing the rock that it was sliding over, and that can be seen. We would love to have had a sign like that, but Lewis and Clark were, they were just trying to get out of here both times. So anyway, another part of this story that, well, there's two signs here. One of them I put in as a small version. These are two large signs that sit in the same place. And one large. This should be of interest to you guys because it has something about some of the rocks that are around here. Missoula is situated beautifully in the home of an ancient lake or sea basin. This is really ancient. We're talking 1,400, 1,500 million years ago. When there was a piece of continent out here that has since made a break for it and nobody knows where it is. They're looking for it in places like Siberia and Australia. And it may have found it, but may not have. So this is a big basin. And the yellow here represents the rocks that were forming there, and Missoula sits in the Belt Basin. You may have heard that term before, those rocks? Yeah, so Lewis and Clark didn't get a lot of the Belt Basin on their route out. They were coming through, you probably can't even see this anymore. They had left Camp Fortunate and were headed toward Lemhi Pass, which turned out to be the Continental Divide. And anyway, so they hit a few of these ancient rocks in their southern extension. And this, interestingly enough, was an older period of extension and creation of basins, a way older period, millions of years older. When this country was also extending and a basin was forming and filling up with sediments that became sedimentary rocks. They noticed them because they were, there's a great big red hill on the way up toward Lemhi Pass, and they were quite impressed with this. It's not that impressive to me, but it's interesting to see where they were really keyed into a piece of landscape and where they just walked right by something that a geologist now would have a heartthrob. But anyway, there's a place called Red Butte there, and they go immediately out of that into a volcanic terrain. And the other sign is about the volcanic rocks that were associated with this earliest phase of the pulling apart of Idaho and Montana. Okay, let's see. Okay, so what you all been waiting for. They finally, you can't see this anymore, so I won't even bother to go over there. They get to Camp Fortunate, they get their horses by that wonderful, one of the sort of oddest moments in history where their Shoshone guide happens to be the sister, the sister of the Shoshone chief that they're trying to make some deal with for horses. They finally have found some people who have horses that might be willing to trade, and the deal is very much sweetened by the fact that there is this relationship. And so they have reached as far as they can go, pushing boats up the Jefferson River. They've got to get horses. They don't know exactly where the Continental Divide is, but they know it's going to be soon. And Lewis goes on ahead and finds it. And this sign sits at Lemhi Pass, right at that top. And it was a moment of huge elation for the expedition, because this is what they had been working for over a year and a half at this point. They had been trying to find the boundary of the Louisiana Purchase, and then they also didn't want to stop there. They wanted to go on to the Pacific, because a major part of what they were doing was trying to figure out how they could get trade routes across this huge landscape, and if they could get trade across. And this little diagram here, which I think you probably can all see, is a schematic. Here's Lemhi Pass. Here's the route to the Pacific. And here's the route to the Gulf of Mexico. And Lewis was a savvy geographer. He knew this was going to happen. He didn't know what it was going to look like on the other side, but he knew it was going to be steeper. There's going to be something here that you may or may not be able to take boats on. And he also had some indication, certainly in the last few days before this, that there was going to be an unnavigable river on the other side. And sure enough, there was. The Salmon River is this part. Right. So here's Lemhi Pass, here's Salmon, Idaho, and here's the canoe camp where they finally were able to make their canoes and get back in the river. It was partly about trees in through here, but it was also about gradient in this part. So, and here's kind of the map view of that, getting to the Pacific as opposed to getting to the Gulf of Mexico. And Lewis, so he gets to the top of Lemhi Pass, and they have this neat moment where they're straddling the most distant fountain, the spring that was at the top of the drainage into the Missouri. And then he goes on up to the top and looks out, and what does he see? The Idaho batholith. Mountains and mountains and mountains. And they'd done this before. They'd seen mountains and mountains and mountains, and it turned out to be navigable. So he wasn't positive that it wouldn't be navigable, although he knew about this. And he has some moments where he kind of accepts that we're going to be into something different. And the other part of it is that the Idaho batholith has not been extended in the way that Southwest Montana was. It's more of a massive mountain range of granitic rocks that have been worked by glaciers and beautifully sculpted, and none of this stuff was really very beautiful to them. It was awesome, but not beautiful. It's all covered with snow. It's late August, and they've got to get across this and get down to the Pacific before winter. And of course, they don't make it before winter. But this was a pivotal moment. He knew it, but he hadn't seen it yet, and he got a chance to see it. This was Geology 101. On the lighter side, you guys know the story, and it's not entirely a geologic story. They get a guide who takes them over Lost Trail Pass, named for the fact that they lost the trail, and broke their last thermometer. They'd been taking all of the measurements that they could of this new country, and I think they took 3 thermometers, and they'd already broken 2, and on the on this sort of awful trip, they break the last thermometer. And then, of course, they find a hot springs, which they were asked to measure the heat for. They get over Lost Trail Pass. They come up the Bitterroot Valley as fast as they can, complaining about the big boulders in the creeks all the way. Get to Traveler's Rest and say, at least we've gotten this far, we can do some hunting. We've been told that there won't be much game, and we can see that it's snowing out there. It's already snowed on us, and this is going to be a tough trip. And it turned out to be the toughest trip that they had on the entire expedition, getting over the Idaho batholith. But before they got too far, they came up from Travelers Rest and passed the Lolo Hot Springs. Lolo Batholith is a 50 million year old blurb late in the history of these igneous rocks, may be actually something that melted out of the Idaho batholith, the crystallizing Idaho batholith, as it was coming up. The pressure was releasing, and as you know, if you've worked with a pressure cooker, you put pressure on things, and they will on something that's hot, and it will stay at a at a denser phase. So you take the lid off the pressure cooker, and the liquid goes to steam. Take the lid off, is solidifying solid batholith, and some of it might melt and go to liquid. And so there's pretty good evidence that that's what happened right here. This Lolo batholith. If you've been to the springs, there's a hot springs there. It's probably controlled by deep fractures in this granite that is pretty massive stuff, and so it's capable of being deeply fractured. Fractured deeply enough that you can get hot or cold water, just rainwater and snow melt to go deep into the earth, heat up, and then come up some other fractures, and that's what's going on there. On their way out, they just had time to say, yep, it's there. Looks like the Indians found it first, made a note of it. And on the way back, they planned an evening at the hot springs. And now they're trying to take the temperature. And they had the same problem at Jackson Hot Springs. Yeah, I'm almost done. Okay, so how do you take the temperature if you don't have a thermometer?
Cook your meat.
Huh?
Cook your meat.
And they cooked their meat at Jackson. But this one was cool enough that they cooked themselves. Lewis and Clark got in this pool along with everybody else. They were all, frolicking. There aren't many baths mentioned in the Lewis and Clark journals, but there is one here. and everybody's having a good time. They're watching the Indians that are with them are jumping into the hot water and then jumping into the cold creek and going back into the hot water. But Lewis and Clark just sit there and time how long they can stand it, because they remembered how long they could stand being in hot springs in Virginia. And as it turns out, Clark can do 10 minutes and Lewis can do 18. So we've got some. This is a relative measurement rather than a numerical one. But they've got that much information, and when they get to Jackson Hot Springs, which Chicagoia showed them on their way back again in 1806, it's too hot to get into. So Clark has, I can't remember which other explorer has them try cooking some meat and seeing how long it takes to cook the meat. And that's reasonable. If you don't have a thermometer, that's a pretty good way to go about it. They probably, you could go back and try that and see what the temperature is. So the geothermal springs in both of these places are not like the Yellowstone hot springs. There's not a body of magma underneath heating up this rock. In both situations, and you won't be able to see that one anymore, it's different, but it's similar in that there's a way to get water that starts as rain and snow melts deep into the earth, heat it up just by the normal geothermal gradient, and then bring it back up on another fault or fracture to be a spring. And there's a lot of... You have a question?
No.
Oh.
I didn't realize that,
Yeah.
that it wasn't because the magma was...
Yeah, in Yellowstone, there's a body of magma a kilometer or two down there in some places, and so the geothermal gradient is hugely elevated there. Around here, it's slightly elevated, but not much. It's just that you can, these deep fractures and deep faults can get the water deep enough to heat up.
How hot can it get with this type?
They estimate that this one, I've got it on here, and let me see if I can remember, that this one got to 181 degrees Fahrenheit at depth. It comes out at 111 degrees Fahrenheit. So it does cool on the way, but not, it's still hot. Jackson Hot Springs is hotter. I don't remember the numbers on it either. Let's see.
On this thing here.
Oh yeah, that's right. They're both. I put both of those on these two. What's Jackson?
Outlet temperature 58 centigrade.
That's hot.
The low is 44 centigrade.
Yeah. Jackson reservoir temperature 125 Celsius. Remember, it's kind of twice as much. Fahrenheit 1.8 plus 32. So 250 roughly at Jackson. They both cool off as they come up, but they stay hot. So they do have to come back through rocks that are cooler, but they keep it warm. So both of these places, they were having a little fun. This one is, Lolo is 7 miles from the Idaho border, so that's as far as we got on the west side, as far as we could. And luckily, the people at Lolo Hot Springs were interested in having a sign, as were the folks at Jackson Hot Springs. So again, private people offering their.
The huge big rocks that are up here, like at Lolo Hot Springs.
Yeah, alley-oop.
I always call them elephant rocks. But,
Yeah.
Are they, what rock formation are they?
That's granite. And
Is that what we always call decomposed granite?
yeah, only the big rocks that you see haven't decomposed yet. Hang on to that vision, and you can all do this. You can do the 75-mile-an-hour identification of rocks. Granite looks like that. Granitic rocks around here look like that. Big, rounded forms with fractures through them, sometimes vertical, sometimes more horizontal. The thing being that this granitic rock, actually, you won't be able to see this, but it's here. There isn't any light at all here, so. Oh, okay, here we go. All right, here's a chunk of Lolo rock. It's a granitic rock. It's kind of weathered. Do you mind passing around that with it? Okay. What you want to do as you look through this is look for little kind of holes where that has some crystals pointing into them. Little tiny holes with crystals. Do you want to just pass this around? Yeah. Anyway, so this stuff forms from a molten mass that has come up from some depth and starts to crystallize before it gets to the surface. And as it crystallizes, the main components, mineral components of this rock are quartz and feldspars. The quartzes are the sort of gray glassy things, and the feldspars are now the sort of chalky white things. And it's a liquid, so they're just crystallizing in whatever orientation they happen to crystallize in. And then what you form is this body of rock that's very massive. And doesn't have necessarily any planes of weakness through it, at least initially, as it's crystallizing. As it cools, it begins to crack, of course, because it's started to shrink. and then also, as it comes to the surface, it starts cracking again because the pressure that was holding it together is being released. And so this massive crystalline body of rock with crystals in all kinds of different orientations begins to break, but it doesn't fall apart like a sedimentary rock with layers. You get a few more or less widely spaced vertical and horizontal kinds of fractures through it, and then water starts moving down through these fractures. And the water begins to weather things. One of the things it does right away is start turning feldspars to clay. And so that weathering has occurred, and then you expose that rock, and the weathered material along the fractures is transported out of there, and you begin to form these kind of rounded shapes. And so that's very typical of granitic kinds of rocks. Lewis and Clark didn't recognize that, but they did recognize that this might be good building stone. They called it freestone. They called anything freestone that you could probably split and make into blocks to make a house. Yeah.
considering they were masons.
Of course, yeah. And they're interested in building communities. That's that's the other thing that they're doing here. So communities need building stones, and so that's what they were doing. But you can identify granite around here, drive fast by it and say, that's granitic. It may not be exactly granite, but it's a granitic kind of rock.
But the rocks up by Lolo Hot Springs are dark, black.
They're black on the surface, or some of them are, but that's a weathering. If you break them open, they're lighter inside. And I forgot to mention this because I was talking about something else, but those little holes that are in there, if you can see them, they're tiny little holes, and there are, as the granite is forming, most of the time the crystals are shoving their way around up against other crystals, and so they don't form nice faces. You don't see beautiful little quartz crystals in most granites. But that one, in those little tiny holes, you see beautiful little quartz crystals or little feldspar crystals, the faces of them growing in there. Those are called myrolitic cavities, and they're an indication that this was crystallizing at such a shallow depth that it was able to the gases were coming out of the magma, and they were actually able to hold little holes open long enough to have crystals grow into them. So that's a big indication that this happened at a very shallow depth. It was still below the surface, but it wasn't.
Some of those crystals are pretty good size.
Yes. Yeah.
They dig them up.
That's right. Yeah, this rock doesn't have the big ones, but that's how they form. It was, you've seen vesicular basalt. Most magmas have some amount of gases dissolved in them, and basalt that flows out across the surface often has lots of holes in it because the gases are coming out as soon as the pressure is released.
What we call
But that-
granite sand, then, is that mainly feldspar?
Say it again.
Is the granite sand that we find those crystals in, is that mainly feldspar?
It's actually mainly quartz, although there are feldspars in it too. And the reason the granite falls apart, granite's weird, isn't it? It goes from solid rock to sand. And that's because the feldspars weather to clay and just kind of wash out and fall apart. And so much of the sand, there's far more quartz in that sand than there is in the rock because the feldspar has weathered away. And it doesn't hold pieces, it just becomes this crumbly stuff because all those little feldspar crystals that are all over in there have fallen apart. So that's it. But even though it's dark, I'd be happy to entertain some questions.
Is there any access to this material except on the sites that here in your collection?
Yes, it's on the web.
Okay.
Let's see, go to University of Montana Western, and Tom has it, yeah. Actually,
The URL is www.umwestern.edu/envirosci, and there's a very big prominent link to Lewis and Clark road signs.
and you can also just Google Lewis and Clark road signs, and it will probably show up. Yeah, they're all there. Tom has been our webmaster on that and put them up. And they're out there in those sites. You'll see them in nice framed, national park looking sign things, and they're out in all these sites.
This is a wonderful resource.
Thank you.
It really is.